Hello again. Hope everyone's feeling good, happy being at home. We want to talk about using the Trig sum laws. This is for all my courses because everybody has to use this, and so it's a good review for some, and well, everyone's talked about it at some point, so it's not review. So let me remind you what they are, and so I'm just going to write them out here. I know that's a little boring, but so there is the addition law for cosine, and then we'll do the addition law for sine. Someone asked me about the difference laws. What about sine of alpha minus beta? And you do that by saying, well, actually, alpha minus beta is alpha plus minus beta, and then use the facts about sine. So anyway, I'm writing in the sine law. So there they are. They're in all the books, and that's the situation. The question is, how do you use these? And these get used in a lot of situations that come up in physics and engineering that involve forces and velocities and positions mixed together in some kind of mathematical model. And so what happens with these mathematical models, for those who studied calculus, you might have seen actually how this works out. If you haven't studied calculus, at some point you will, and you'll see that this is the kind of answer that appears. So solutions to these problems are a combination of cosine and sine. So what you have is what's happening for any particular x is some number a times cosine of x plus another number b times sine of x. And what we can do is use the addition laws and difference laws for sine and cosine to figure out this as one particular sine or cosine function, kind of depending on your mood. So here's how we're going to do it. What we want to say, if we're going to use, say, the sine law, is that that first coefficient is going to be the sine of something. So instead of a, I'm going to call it sine of alpha. And instead of b, we're going to have cosine of alpha. So we're imagining that we have some angle alpha that we don't know yet, and that a and b, well, they can't be the sine and cosine of that angle most likely, because sine of alpha and cosine of alpha are always stuck between -1 and 1. So there's going to be a trick to how to do that. And that involves Pythagoras, because everything goes back to Pythagoras. So let me draw you a picture that's going to show you how we're going to handle this. So what we're going to get is a right triangle, and we've got some angle alpha, that's our unknown, and two of the sides are known to be a and b, and by Pythagoras we can fill in the third side, so let's do that. And while we're at it, I'll throw in a reminder that that's a right triangle. So the third side of a right triangle, the hypotenuse, is sum of the squares of the, the square of the hypotenuse, sum of the squares of the other two sides. So what we have now is sine of alpha is not a, that's what we were looking for, it's a over that square root. And the cosine of alpha is not b, it's b over that square root. So what we're going to have to do is multiply through by that square root to get something that that is actually sine and cosine. So I'm writing that out. Take some time to write that out, sorry. So there's that coefficient that makes the first coefficient a is actually making it a over that square root is the sine of alpha, and b over that square root is the cosine alpha. And we recognize that as being, in this case, the square root of a squared plus b squared, the same square root all the way around, times the sine of x plus alpha. So that red is the addition law, and the black is the other half of the addition law. And so now we can graph what's going on. First thing to note is that we have a translated sine curve, translated so that it starts at minus alpha, and we've changed the amplitude to that square root. And so that's going to tell us how to do the graph. I'm actually trying to do this graph to scale because I'm working on gridded paper and I can. So there's the typical grid that we make for a sine curve, and I'm going to draw in the curve. Trying to do a good job here. There's the sine curve, and now we can fill in with the translation and the change in amplitude. So I'll do that in a different color. So the amplitudes are giving us that the curve varies between square root of a squared plus b squared and minus square root of a squared plus b squared. And the whole thing starts at minus alpha. So the other points are pi over 2 minus alpha, 2 pi over 2 minus alpha. Don't simplify in your head. 3 pi over 2 minus alpha, and 4 pi over 2 minus alpha. And that's actually a pretty accurate graph, considering that I did it freehand, of the function that we started with, a times cosine x plus b times sine of x.